Alright, all stars, it's Algebra 2, Module 3, Unit 8, Lesson 4, Properties of Exponents and Radicals. Let's rock and roll. Alright, our first example here is to take 7 raised to the half power times 7 raised to the half power. Well, folks, we have same bases there, don't we? Whenever we have same bases, we multiply, we keep the base, and add the exponent. So what's a half plus a half? You got it. 7 to the whole number 1 and 7. Anything in the first power is 7. That easy. Now we go to D. In D, we've got 64 to the third raised to the half. So it's a power rule. So I'll keep the base here, 64. And a half times a third is 1/6. And from the previous lessons, I raised the 64 to the first power, which is 64. And the root is the next part. So this is really the 6th root of 64. Well, break it down. 6th root. How can I break down 64? Well, if you take a look at it, you get 8 times 8. And then 8 times 8 can be broken down into a whole mess of 2's. And actually, 8 is 4 times 2, which is 2 times 2 times 2. And another 8 is 2 times 2 times 2. And if you look, I got 6 of all that set. So the grand answer on this turns out to be, believe it or not, 2. And yes, you can check it on the calculator. If you throw 64 to the third, raise the whole thing to half, the calculator will give you that answer. Okay, let's go to the next set of exercises. Okay, this time now is the directions say write the expression in the form of b to the m over n for positive things. So basically, write it still as a fraction. Well, what happens when I multiply b to the fourth times b to the fourth? I get b to the 1/2. And I'm not taking it any further. Just leave it that way. As far as it goes. Remember, you're adding exponents. Quarter and a quarter makes a half. Okay, next one. This one's a little more difficult. In order, when we go and we do this, we got b to the 1/5 times b to the 3/4. I have to add the exponents. Keep the base and add the exponents. They do not have common denominators, so you must change them. Smallest common denominator will be 20th. So I have b to some 20th. Times b to some 20th. Well, how do I go from 5 to 20 here? I multiply by 4. So I get a 4/20 here. That's the same thing as 1/5. And this one, how do I go from 4 to 20? It's times 5. 5 times 3 is 15. So remember, we're multiplying, so we keep the base, add the exponents. 4 plus 15 here on the top makes 19/20. And that is my answer. That's in number 3. We'll be doing number 2 in class. All right, so that's how we leave it with fractional exponents. Okay, so we're doing more of the same here. Taking b to the negative 1/5 times the 2/3, or actually raised to the power 2/3. That's your rule for power rule. So you multiply. So negative 1/5 times 2/3. Well, negative times positive is negative. 1 times 2 is 2, and 5 times 3 is 15. Can't do anything else with that. All right, now number 3, same base of 64. So add the exponents. They do not have common denominators, so I've got 64. And 3 and 2, the first common denominator is 6, so change it to 6. Times 64 raised to 6. Once again, how do I go from 3 to 6 is times 2, so this turns into 2/6. How do I go from there? This is times 3, so that's 9/6. You multiply, so you keep the base, add the exponents. So that and 11/6. Okay. So now, our directions though on this one said, if the numeric expression is a rational number, b back here, number 2, was not a rational number, then write your answer without exponents. So guess what? There's a rational number. We got to deal with this without exponents. So how do I deal with that? Well, that's 64. And I have to take the 6th root of it, the bottom, and the whole thing, the 11th power, or stick the 11 inside. Well, we already did the 6th root of 64 before, if you remember. That's really the 6th root of a whole mess of 2's. Actually, 6 2's. So that means the whole thing comes out as a 2. So that's 2 to the 11th power of which you could multiply, and you will get a grand total of 2,048 when you did that. And you might remember that from a chart we did a couple lessons ago as well with the powers of 2 and the exponential. Okay. All right, so let's move on. Almost done. A couple more. All right, so I lied. We're only going to do one more. But basically, we're going to write with an outer expression here, this whole problem, and then evaluate when x is 50, y is 12, and z is 3. So, if I take the cube root of this whole thing, let's bust this thing up. I got the cube root. 54 is 2 times 27, and 27 is a perfect cube. It's 3 times 3 times 3. Then I've got y to the 7th, so if you want me to break that up a little bit, that's really y to the 6th and times an extra y, so there's your 7 y's. And then I've got a z squared, which isn't going to help at all. Okay, so what happens here? Well, the 3's come out, so I get a 3 out in front. Because I got a pair, remember, I got an exponent of 3, a cube root of 3. This is 2 sets of 3 y's, right? So a y squared comes out, meaning I got 6 y's, you circle through sets of 3 y's, they come out. This y is not coming out, this 2 is not coming out, and the z squared is not coming out. So I'm left with the cubed root of 2yz squared. Okay, so now that's as simplified as it's going to get. Now let's go and do what they said back here, which is to plug these numbers in. So I've got 3 times y squared, y is 12, so that's 12 squared, times the cube root of 2 times y is 12 times z is 3, and it was z squared. So I've got a 3 times 144 times a cubed root of, let's do 2 times 12 is 24 times 9. So I could replace that whole thing, if I do that, with 216, I believe. So it's 3 times 144 times the cubed root of 216. Well, 216 is a perfect cube called the number 6. So it's 3 times 144, because 6 times 6 times 6 is 216. So I can pull that out, no radicals left. And my final answer here is 2,592 if you multiply all that together. So not too bad. All right. We will do all the other problems in class, so don't worry about them, and I will see you then.